Pythagorean Theorem, if I can spell it, is arguably the most famous theorem in all of geometry, and there has been hundreds of proofs published proving it. And I want to cover in this video one of the, I think, most elegant proofs that has been published. Before we begin, let's recap on what Pythagorean theorem is. Whenever you have a right triangle with side lengths a, b, and c, you know the a squared plus b squared is equal to c squared, where c is the longest side, or the hypotenuse, or the side opposite the right angle. And this seemingly simple theorem has an immense amount of applications, so it is an extremely important theorem to prove. So let's begin. Let's say you're given a square, and we're going to draw some triangles inside. Let's make this the first one, make this the second one, make this the third, make this the fourth. So what do you have? You have four congruent triangles, you have four equal triangles, and you have a square at the center. That's cool, but let's assign some values to a triangle. Let's call this side to be A, let's call this side to be B, and let's call the hypotenuse to be C, the longest side to be C. So you have the same thing going on for this triangle, that this thing C, this is B, this is A, and so on. Now let's look at what's happening. How do you find area of the entire thing? How do you find area of the blue square? And you may say that's just side times side. And what's our side? Our side is a plus b. So the area of a square is equal to a plus b squared. And you say, okay, that's good. Now what's special about that? Is there another way of finding area of a square? And I'm going to tell you, yes. You can find area of one of the triangle, multiply it by 4, so you have area of 4 triangles, and you can find area of the inside red square and add them up. So how do you find area of a triangle? That's base times height divided by 2. So area of this triangle is equal to a times b divided by 2. And how many triangles do you have? You have 4 of them. Now, what's the area of the red square? The side length is c, so our area is going to be c squared. So this thing is also equal to area of the blue square. Now, so you know this thing, and let's simplify this. AB over 2 times 4 is same thing as 2AB, because 4 divided by 2 gets you 2. So you know 2AB plus c squared is equal to a plus b squared. Because both of them represent the area of the blue square, they have to be the same. Now, how do you expand a plus b squared? Hopefully you know it's a squared plus 2ab plus b squared. If you do not, that's more than fine. You can multiply them out. A plus b times a plus b is going to be, you can either FOIL it, let's FOIL it first, multiply the first terms, a squared, multiply the outside, a times b gets you ab, multiply the inside, b times a is same thing as ab, and multiply the last terms gets you b squared, and this is a squared plus 2ab plus b squared. So you know 2ab plus c squared is equal to a squared plus 2ab plus b squared. And since you have 2ab on both sides, you can subtract it out. So 2ab cancel out. And what do you have left? You have c squared is equal to a squared plus b squared. And we had a triangle with a, b, and c, where c is the hypotenuse. So we just proved the Pythagorean theorem.